Hey all, this is TCGM. Welcome to my first GameMaker tutorial for the Faucet networking extension. I will be showing you how to create a server-client multiplayer system using Faucet networking. Please note that this is not the only way to do it, but merely how I choose to code. If you're not familiar with GameMaker, please check out its link in the description. Likewise, Faucet networking has its link in the description as well. Before we get started, this tutorial will function in both GameMaker 8.1 and GameMaker Studio. I have Studio, so I'll be using that for this tutorial. The first thing you do is to add the Faucet networking extension to GameMaker's used extensions list. To do this, first click the green little plus icon here. We of course need to install it. Click Install, and then click the next Install button. Navigate to where you have the extension and open it. I have it on my desktop for ease of access right here. There we go. Click OK. Click the Faucet networking name in the Available Packages panel, then click the blue arrow that appears between the panels. This installs it. Click OK. Save. As you can see, it is right here in the Used Extensions thing, folder, majig. Okay. Once you have that done, we have some scripts to create. They are client init, server init, player init, server end step, server begin step, client begin step, player step, and player draw. There we go. We also need a few objects. These are net manager, menu manager, object player, and object local player. Save that. Excuse me. The net manager is the controller for the server-client communication code. The menu manager will set some global variables from the menu. Object player is the multiplayer representation of another player, and the object local player is the client's player object. Finally, we have to set up some constants. These are essentially functions I can reference later, i.e. player position, that I will know have the same numeric value on both the client and server. To do this, we can click Resources and then Define Constants. Doing it this way, you don't need to create a fancy table, remember which message is which, or anything else. So I'm going to create client ID and set it to 1, and then player position and set it to 2. The first thing we should do is set up the initialization libraries for client, server, and players. These init scripts create variables we will reference later. It is usually good to use the same variables client and server side to limit the amount of variable translation we have to do. Let's set up some basic variables in each of the init scripts. So that, and that. Here you go. You can pause to see them all if you like. Yeah. This is identical for every single one. We then need to tell the server to create a data list and a data structure list, and then define two more things: the port and the incoming socket, which is just a variable we will use later. So yeah, you can look at this if you want. Then for the client, we need to have it also define the server host and server port, and then global client ID, and then the controller variable to see if we have joined. Now we need to tell the client to initiate a connection to the server. This is accomplished using this code. This code does two things. One, it opens a connection over the TCP protocol to our defined server IP and port. Two, it sets the limit of bytes that can transfer at once very high. You will never reach this limit. Let's also instruct our server to open a listener. This code creates an active connection acceptance listening port on the machine. Without this, the server would not be able to hear incoming client connections. It also checks to see if there is an error with the listener, and if there is, quits back to the main menu. At the end of both client init and server init, let's plop this little code to create our local player. The client also needs to create the server's player with the global client ID of 1. That's set across the entire code that I wrote, just because stuff. So, our setup is complete. Before we move on to any other scripts, let's tell the net manager which of these to run based on a global variable. So, add a create event, a code block, and pop this baby in. This code takes a look at the global serve mode variable that will be set from the menu manager, and then runs the appropriate case, which contains the correct init script. A switch statement is basically an if statement which looks at a variable and then can do things based upon the state of that variable. There we go. Let's write the server end step script now. This is the script that will actively listen for incoming connections as well as send the state of the server's local player to the clients. There are two sections to this code, so let me explain them each separately. This code listens and accepts incoming connections on the acceptor socket. If the socket actually has a connection, then it enters the next part of the code. It sets the socket buffer limit stupidly high, then creates the temporary variable O, which we will use to control the new player temporarily. It then creates an instance of the player on the server, adds the ID of that player to the client list, assigns a client ID to the player, and then writes a message to the client that just connected containing that client ID. Note, this code can be insecure. It is best to look up the client ID from a data structure list, but I'm lazy. Anyways, the message writing code does four things. 1. Tells the client how many bytes are expected, the header. 2. Writes an unsigned short to the buffer containing the client ID constant, a number both the server and client understand. 3. Writes the client ID. 4. Sends the message. The code then tells the player that its socket is the incoming socket number, and then resets the incoming socket number to listen again. Note, the socket is still existent and operational and is stored on that player. Here's a little thing which confused me, and I should get it out of the way right now. You may be asking in the screen, why didn't TCGM just write 2 bytes? Why 4? I only see 2 messages. And you'd be right, except that shorts and unsigned shorts are 2 bytes long. All the byte lengths of possible messages are right here. They should be appearing on the screen now. Bytes are 1 byte. Shorts are 2 bytes. Integers are 4 bytes. Floats are also 4 bytes, and doubles are 8 bytes. Strings are 1 byte per character contained within, and Faucet Networking's writeString function does not include how long the string is. Thus, if you intend to send strings, you'll need to get the length of the string, add it to the byte count of a message, and also send that string length along before you read the string to tell the receiving end how long of a string to read. Back on track, here's the second part of the server end step script. It's got some comments on it. This code tells all the object player objects to write a message containing the player position constant, the message type, the server's client ID, default 1, then the X, Y, and image angle values of the object local player object, then send the message. Quite simple when you break it down, really. With this in our memory, we're going to write the client begin step script now. Like the last script, this one has 2 parts I'll explain individually. Damn, quite a lot of code, huh? Let's break it down. First, the code checks for an error with the server connection socket. If one is found, i.e. a connection cannot be detected, then it closes the game. The next part is a while loop, which remains true while the client receives data through the global socket. This is what the TCP receive function is for. We set the next byte is header variable to true in the initiation script, so the if statement will see that it is true and execute the code inside it. This code reads an unsigned byte, 1 byte, from the socket as the message byte count, and then sets next byte is header to false to break the if function. As the if function is no longer valid, the loop skips it and continues to the switch, which reads the message type as an unsigned short and checks it against the constants. The rest should be easy to figure out based on your current knowledge of the system. We also need to send our client state to the server. This section of code does that, but only after we have received a message from the server first, to prevent any errors. That's what this variable is for. As you can see right up here, when it receives the client ID message, it sets join to true, meaning that the server has communicated with us. Now for the server begin step script. I'm not going to explain this, as it's just a repetition of things we have written before. Save that. So now we have all 5 of our networking scripts. Right now they merely transfer data. We do not have object player or object local player doing anything with it. So let's code something easy. I need to make a triangle-like image to denote the image angle direction of the players. Let's go here. Make a simple one. Where the hell is the triangle? There we go. There we go. Okay. Center. Say this as sprite player. And set the object player sprite to it. There we go. And the object local player sprite to it. Note that in GameMaker, image angle is based off of a 360-degree angle. However, the 0-degree mark is at the right of the sprite. There. Right there. Instead of up here, it's there. I am going to add some simple code to both player objects for basic movement and sprite rotation. You do not really need to pay attention to this, although you can if you like. So, an object player, since it's controlled via it's controlled via network things and not local player things, we only need to add a create and draw event. We do not need to add a step event. We will need to add a step event to the object local player, however. So, in the draw event, we put player draw, and then in the create event, we put player init. Quite simple. Now, in object local player, we need to add a step event, a draw event, and a create event. And like in the other player object, we need to put player init in the create event, player draw in the draw event, and player step in the step event. Now, in order to differentiate between what an object player is and what the local player is, we're just going to have this. Nope, never mind. I'm being an idiot. Okay. So, we need to open up player step, and put this stuff in here. This is simple movement code. You don't really need to pay attention to this, but you can if you like. Then we need to put this in there in the player draw event. And I accidentally forgot to copy some things into here. So put this there, and voila. Okay. Great. Now we just have to tell our net manager to run these scripts correctly in the correct events based on the global serve mode variable, and then tell our menu manager to set some starting variables at the beginning of the game. First, for net manager. Using the switch statement we used before, we'll simply replace the script names in the events. So, we need to add a begin step and an end step event. Now, there is no client end step, so all we need to do is remove this and change this to end step. Then in the begin step event, we need to change both of these to begin step. Ta-da! And yep, okay. On to menu manager. I'm going to use H and C as host and connect, but this can be accomplished any way under the sun as long as you set the correct variables. At this point, you have everything you need to successfully communicate back and forth from a server to a client and vice versa. Everything since Net Manager's finishing has been icing on the cake. We just need to create a couple of rooms and add your objects and we're set. So, in the step event of Menu Manager, we shall put this code. And then in the create event, we shall put this code. Quick note, the IP that you use in Faucet networking has to be in the form of a string. It cannot be numbers, i.e. like this. It has to be like this. Yep. I'm just going to use localhost for now. Okay. So, we need to create two rooms and name one room room menu, and the other room main. Place net manager into room main and menu manager into room menu. Floating point division by 0. Floating point division by 0. There we go. That was weird. Fix your software, yo-yo games. Make sure room menu is on top. Create an executable for this project. Save it wherever. I'm going to save it to my desktop. So, desktop. Ta-da! So now, we need to launch two copies of this file. One is this. So we're just going to use this as the hosting. And this little thing will pop up. It will ask you to unblock it. Just allow access. When that shows up, that signifies that the code is working. So that's a very, very good thing. Then open up another one and hit C. You see how it popped up? There you go. This is the one I'm controlling right now, by the way. That one is not. So, the code works. There you have it. Server-client multiplayer code, right from the comfort of your living room, or your bedroom, or wherever you're watching this video right now. Hell, you may be on a bus in New York. Thank you for watching my first GameMaker tutorial. The link to the finished GMK file for this project in the description, along with links to GameMaker and to Faucet networking. This tutorial, the script I've been reading off of, is also in the description. Have a pleasant day.